Imagine space, not as an empty void but as a giant, invisible grid. Now, picture a star, a planet, even you, making that grid bend. Imagine clocks ticking at different speeds, not because they are broken, but because of where they are. Time itself stretching and squeezing. This isn't a movie. This is our universe. All from one powerful idea Einstein found. We are going to explore one of the wildest things his math predicted. A secret about time you were never told. It affects every single one of us, every single day. From a falling apple to the dance of planets. Space bends, light bends, time bends. Your GPS works only if we correct for it, and it can separate twins by time itself. At light speed, time stops. We've heard ripples in spacetime from colliding black holes. Follow Einstein's math and something strange happens. Time is not universal. Let's slow things down. Forget everything you learned about gravity being a mysterious force that pulls things down. Einstein gave us a new picture. Space and time are not separate things. They are woven together into a single, four-dimensional fabric. He called this fabric space-time. Think of it like a giant, stretchy rubber sheet pulled tight. Diagram, flat grid, then the same grid curved by a large sphere. This sheet is the universe. It is the stage where everything happens. Every star, every planet, every person exists on this sheet. Gravity is not a force, but a feature of geometry, the key to everything that follows. Now, let's put something on our rubber sheet. Imagine placing a bowling ball in the center. It bends, it curves. The heavy ball creates a well in the fabric. This is what massive objects like the sun do to space-time. They don't pull with invisible ropes, they warp the fabric around them. The more massive the object, the deeper the curve it creates. This is the heart of Einstein's general theory of relativity. Gravity is the curvature of space-time. Roll a marble not directly at the ball. If the sheet were flat, it goes straight, but the dip curves its path. It looks like a pull, but it isn't a pull. The marble simply follows the straightest possible path through curved space, a geodesic. That is what we call an orbit. The moon follows a straight line through curved space-time. This was a huge shift, from forces at a distance to the shape of the universe itself. Planets circle the sun because they're caught in its deep gravitational well, like marbles around a giant funnel. This simple analogy remains our most powerful tool to visualize the hidden architecture of the cosmos. Imagine you are a tiny ant trying to walk straight near our bowling ball. You think you walk straight, but your path curves with the space you're in. You feel no sideways push. You follow the contours of your world. Planets do the same, following geodesics, straightest lines in a curved universe. We can see space bend during a total solar eclipse. The sun's gravity bends space-time. Starlight follows the curve, so stars appear shifted. This is gravitational lensing, a giant invisible magnifying glass in space. Astronomers use it to see impossibly faint, distant galaxies. A nearby galaxy cluster acts as a natural telescope. So, mass tells space-time how to curve. Big mass, deep curve, small mass, shallow curve. Everything, you, me, even light, must follow these curves. Space is not a fixed backdrop, it's dynamic, shaped by matter and energy. But Einstein didn't just curve space, he curved space-time. And that time part is where things get really weird. This is where we find the glitch. If mass bends space, what does it do to time? According to Einstein, it slows it down. The deeper you are in a gravitational well, the slower time passes, compared to farther away. Imagine the fabric thicker near the bottom, motion through it slows. That's a rough analogy for time. Gravity warps time. Two perfect clocks. One on a skyscraper rooftop, one in the basement. Let them run for a year, bring them together. The basement clock will be slightly behind. Time itself passed more slowly there. This is gravitational time dilation, not a clock error, but a feature of the universe. The flow of time is not constant. It is relative, depending on your position in a gravitational field. You might think time slowing is abstract. You'd be wrong. This glitch is at work inside your phone. GPS relies on satellites carrying precise atomic clocks. They move 13,000 kilometers about 20,000 kilometers up, in weaker gravity. Weaker gravity makes their clocks tick faster than ours. General relativity says they gain 45 microseconds per day. That tiny difference would wreck GPS, drifting 10 kilometers per day. GPS measures signal travel times at light speed to compute distances. With at least 4 satellites, your phone pinpoints you via trilateration. It only works because engineers built in Einstein's corrections. Satellite clocks are intentionally set to run a bit slow to cancel relativity. So, every time you find a coffee shop, you're using one of science's strangest ideas. Let's return to Alex and Sarah. The mix-up was just the beginning. Her missions kept her far from deep gravity. His work kept him close. Years went by. He felt normal time. She lived a touch faster. After 5 years for her, he had barely aged 4.5. They laughed it off, but the gap was real. Across a lifetime, the difference compounds. You don't need a spaceship or a black hole to feel this. Try a simple thought experiment. Throw a ball straight up. It rises, pauses, falls. Now imagine a photon. At light speed, time doesn't pass at all. Higher up, time ticks a hair faster. Lower down, a hair slower. So, the up journey takes a smidge more time than the down. Einstein's weirder answer: objects follow the path that gives them the most time. The principle of maximal aging. Falling is just a way to live longer. In 1907, his happiest thought, "Freefall feels weightless," grew into 1915's field equations. In 1919, starlight bent by the sun confirmed the theory. We photographed a black hole's shadow and heard space-time ripples from colliding giants. So, here's the wild glitch. Time is not universal. Your personal clock, your aging, your moments, is subtly altered by gravity everywhere. Slower at sea level than on a summit, slower on Earth than in GPS satellites. Near a black hole, it nearly halts. Next time you look up, remember, they rest in dips and curves, and so do you. If gravity can change the speed of time, what else might not be as constant as it seems?